Number 86, consider the equilibrium, and then they give us this equation, which I just wrote out a little bit bigger. So they said that we had 4 NO2 gas plus 6 H2O gas comes to equilibrium with 4 NH3 gas plus 7 O2 gas. And then we have letter D out of the whole bunch. So they said if the change in the pressure of NO2 is 28 torr, as a mixture of the 4 gases reach equilibrium, how much will the pressure of O2 change? Okie dokie. So they're telling us that the change in the pressure of NO2 is 28 torr. Here's NO2. So we know that this is either going to increase or decrease. We don't really know. We don't know if this is a piggyback question off of letter C, but it might be, because that we talked about change in letter C. If you want to go get a refresher, you could always go back to that question if you guys are on the playlist. But in this case, we know that there's going to be a change in 28 torr. Now, they didn't say anything about being an ATM, so I'm just going to keep it in torr. It doesn't really matter because we're not finding out equilibrium pressures. We're not using the K value. So all we have to figure out is what's going to happen to the O2. So here's O2 all the way on the end over here, and here's NO2. Okay, well, we could basically use our ratios, right? If we're going from one compound to another, this is kind of going back to stoichiometry. All we have to do is just use our stoichiometric ratios, aka the numbers in the front, right? So if I just say that I have 28 torr, and this is corresponding with NO2, I could just times by a ratio in which I put the NO2 on the bottom, and I put the one that I'm looking for, O2, on the top. So, in this case, the only thing that these have in common, remember, is moles, right? We can always make a relationship between the moles based off of the balanced equation. So I can make a relationship between the moles of O2 and the moles of NO2, and that's coming from the coefficients. There were 4 moles of NO2, so I'm just going to put a 4 there. Oh my goodness. I'm going to put a 4 there. And then there's 7 in front of the O2, so there's 7 moles of O2. Okay, so now, basically, we can just times it, right? The torr, the NO2 is going to cancel out with the NO2. The O2 stands, right? And the unit moles are going to get canceled. So now you're just left with torr of O2. So let's see, 28 times 7 divided by 4 is 49. Torr of O2. So if this is decreasing by 28 torr, since this is on the opposite side, this would have to increase by 49 torr. Or if this was increasing by 28 torr, this would decrease by 49 torr. But the number is more important. So, hold on. What just happened here? So maybe I'll just get rid of these because it could have been opposite. They didn't say. The main answer is that it's going to change, no matter if it's increasing or decreasing, by 49 torr. And that is your final answer. And I think we're done with this question. So 86 is done. We're almost done with the chapter. So let's keep working hard, guys. Equilibrium is almost done. And then we go on to newer things. All right? So hang in there. I'll see you for the next question. Thank you so much for viewing the video, and I'll see you all later. Bye-bye.